We're going to take a look at this. This is a hydrate problem. So hydrates are ionic compounds that have a fixed ratio of water molecules chemically bonded to them. And their formulas are written a little bit odd. They use this little dot between the ionic formula and the amount of water, but they're chemically bonded in there. It's a fixed amount of water that's chemically bonded in with it. And the way you would name it is you would name it copper 2 chloride, because that's the name of CuCl2. And then since there are two waters, you call it di, the prefix for 2, hydrate. Na2CO3.H2O would be sodium carbonate monohydrate. And CoCl2.6H2Os, that would be cobalt 2 chloride hexahydrate. So that's their names, that's their formulas. I'm going to show you real quick some examples of some hydrates and how you can actually go through the process of dehydrating them by heating them up. All right, I have a couple of different substances that are defined as hydrates. Each of these has water chemically bonded to them. The substance on the left here is cobalt 2 chloride, and it is a hexahydrate. And then over here I have this blue substance is copper 2 sulfate, which is a pentahydrate. And the water is chemically bonded into them. The substances don't look wet, they're completely dry. But if I heat them up using this Bunsen burner, I should be able to drive off the water, and we'll notice some things change. So for instance, with this cobalt chloride, you may notice there's some steam coming off. You can hear sound, you can see the water that is coming off in there. You should also be able to see that the solution is, the chemical starting to turn a blue color instead of that magenta color that it was before. You can see all the steam being given off. That's just one example of a hydrate. It's now turned that blue color. You can see all the water vapor that's condensed in the mouth of the test tube. So we'll set that one aside for a minute and we'll take a look at the copper sulfate. There's immediately some water vapor condensing on the inside of the test tube. And you may notice the outside of this substance is starting to turn white in color. Let's crank up the heat just a little bit. You can see the steam coming out over here. You can see all the water vapor that's condensed. As the water is driven off, the copper sulfate goes from being that blue color to this whitish gray color that we're getting. There's huge amounts of steam being given off. Lots of water that's chemically bound in there that's being driven off. So we'll set that one aside as well. Now that we've allowed these to cool off just a little bit, if I add some water to the cobalt chloride, you'll notice it starts to turn back to that red color that we had before. And the copper sulfate, you can see that some of the water that's dripped down from the condensation is starting to turn it a little bit blue on the sides in that one as well. So this process is reversible. So that's some examples of some hydrates. Okay, so we're going to look next at how we do hydrate calculations. These work very similar to empirical formula calculations, where first what you have to figure out is how much of the anhydrous compound, the compound minus the water, do you have, and how much water do you have. So you have grams of each of those. Then you convert grams into moles, and you divide by the smallest number of moles, and that gives you how many waters there are. So let's look at an example. So 3.97 grams of hydrated copper 2 sulfate is strongly heated. The anhydride weighs 2.54 grams. Determine the formula of the hydrate. So we have 3.97 grams of copper 2 sulfate with some amount of water we don't know. And after you heat it up and you drive off the water, it weighs 2.54 grams. So if we do some simple subtraction, if we take 3.97 and we subtract 2.54, the mass that was lost is 1.43 grams of water. And the anhydride, by the way, is just the copper 2 sulfate, the CuSO4, that doesn't have any water on it. So now we need to convert grams into moles, just like it's an empirical formula problem, where 1 mole is 159.62 grams. That's the mass of copper plus sulfur plus 4 oxygens. And 1 mole is 18.016 grams. So we do our little calculations. And we get 0.0159 for the copper 2 sulfate and 0.0794 for the water. So now we divide both of these by 0.0159, which is the smallest. And I'm getting essentially 4.99. That's basically 5. So this is CuSO4.5H2Os, or copper 2 sulfate pentahydrate. So that's how you actually work through a hydrate problem. The last thing that I'm going to do as part of this lesson is I'm going to actually demonstrate a Hydrate Lab. And I want you to follow along. You're going to need to take some notes. And I want you to see if you can calculate the formula for the hydrate that's done in this demonstration. And then I want you to add your calculations to a private comment on this assignment when you submit it. So good luck. For this experiment, we're going to find out what the chemical formula is of a hydrate. So in order to do this, I'm going to first determine the mass of a crucible that's empty, and it weighs 10.690 grams. So 10.690 grams. You're probably going to want to write this down as well. I'll now add some magnesium sulfate to the crucible. And the crucible now weighs 15.684 grams. So 15.684 grams. I've placed this crucible with the magnesium sulfate onto this clay triangle, which I'm supporting using a ring stand over the Bunsen burner. And I'm now going to heat the magnesium sulfate up in order to drive off all of the water. So we're going to look at what's happening in here. So we begin heating this up. Start to see some liquid bubbling off of the sides of the magnesium sulfate. start driving all this water off. And we'll check back in on this in a few minutes to see where we're at. We can still see a lot of water bubbling off in there. It's still in the dehydrating process, so we're gonna keep heating this up until it gets really hot here. It seems to have mostly dehydrated now, but I can still hear a little bit of sizzling. So I'm going to let this run for another minute or two, and we'll check back in once again. Now that the magnesium sulfate has cooled off, we can see that it has a new mass of 13.155 grams. One last thing with this magnesium sulfate, which is now, it's cool to the touch. If I add some distilled water to it, you might be able to see that a little bit of steam is given off in the process as it rehydrates. And it may be difficult for you to actually see this, and you definitely can't feel it, but it definitely gets quite hot again. Because if we had to put heat in to drive the water off, then heat is released as the water is reincorporated back into the hydrate. So, using this information, see if you can calculate the formula of the hydrate. And you need to make sure that you subtract out the mass of the crucible from each of these weights that we have done. Good luck.